Good morning, ladies and gentlemen. My name is Jarosław Tworóg. I hope that all of those who participated in the inaugural session and listened to Pulse Common, they already know that Industry 4.0 is closely connected to 5G networks.
Two guests from abroad. I see one guest from Latvia and one from Germany, Oliver. Please excuse me, just to be a better understanding, I'll do this presentation in Polish, okay? Because it is mainly what's from your material, so it doesn't make any sense to do it in English. Excuse me. Proszę Państwa, skupię się na
Ladies and gentlemen, I will focus on the new investment cycle, which is investment in the digitization of manufacturing facilities. This wave of digitization is termed as if, or conceived as digitization that reduces the impact of industry on the environment, because we can better use our resources and we can modernize technology or replace the technology to even further decrease impact on the environment. It's not our role to study environmental issues, but our role is to take all business opportunities to develop our industry while also improving the status of the environment and to decrease pollutions. And in this way, we refer to the European Green Deal. At the beginning of our discussion, I'd like to state that for 4.0 networks are a fact. They solve a number of business problems that we face. So there is a reference architecture developed for 4.0 industry. There's a number of basic notions defined. Now this leads to networked economy, networked industry. And this is the beginning of something that of what we call circular economy, and there are some important implications for industry arising from here. Now, I showed this slide 3 years ago already. This shows two types of digital integration within a company and outside the company. The first type is a vertical integration within businesses, that is equipping all machines, processes, and managing elements with digital modules. And back then we focused on that, and today we're going to shift to the adjustment of facilities, connecting one with another. Now, if we talk about networking between facilities, so we have a set of networked devices within a plant. How can we connect plants? Now, how about the networks? What will the networks look like? Why am I using a future tense? Right now, this level of digitization has covered 2 to 4% of the world's industry, mostly great international manufacturing corporations. That's the main site of implementation. There are some implementations in NAFTA or the EU in economic regions, but still it's only the beginnings. 2% is not much, but we are already sure that the great benefits derived from, let's say, nodes into networks. So this expansion of chains of value has led to a situation where the process is accelerating. So two scenarios are possible. First of all, we can focus on the fact that we deal with a multi-level network where we have 30 billion connected devices. In the near future, about 2025, we will have perhaps 75 billion connected devices. That's billions of devices. Indeed, what is going on right now in terms of devices connected within networks, initially those were devices outside facilities, that's external infrastructure, some additional buildings. But right now, the increase in connected devices, the bulk of that happens inside facilities. So we are shifting from IoT to industrial IoT, IIoT. Now we can take a different perspective on these networks as connected clusters integrated via clouds, multi-level structure functioning at different tiers in different business segments, and we must not strive to develop a homogeneous network. Indeed, I think what is going to arise is an extremely heterogeneous network, and as the various sectors are being integrated, we can say that the internet as such does not exist. What we have a whole plethora of partial networks connected by certain protocols that collectively are called the internet. So we can say that we already have Industry 4.0 today, but to date, few people understand Internet of Things as Industry 4.0. We need to emphasize that Industry 4.0 is a full implementation of industrial Internet of Things. The main reason why this is being done in mass-producing plants is a better use of resources owned by companies globally. So in this case, the main driver for the process is money. So how about SMEs? What's their perspective? They are basically outside this sphere, and we started our discussion yesterday from this thesis. But obviously they're willing to participate. They may be connected, especially the more innovative ones. They kind of cooperate with the larger ones, but they are suppliers of the big ones, contractors, so they can be connected to the larger companies by the industrial Internet of Things, but they are not equal partners. But in SME policy, we need to strive to make sure that all segments take advantage of these solutions. They derive benefits, so we would not like to have excessive transfer value added from small to large companies only because of economies of scale and the fact that we lack appropriate regulations. Now, how about benefits? In large companies where the machinery is used very often 24 hours a day, and the knowledge of production processes are much higher, those benefits may reach 30%. Obviously depends on how well a plant was organized before the implementation of IoT. In the case of small companies, the British are prone to say the sky is the limit. Indeed, the company has one shift work model, but they could work 3 shifts. So some resources that are used 5 5% of the time, but they could be used all the time. Well, it's very difficult to estimate the value of benefits, perhaps between 40 to 100% increase in productivity. In addition, due to connectivity, we can develop co-opetition, which has a Polish equivalent, konkuperacja, but we have a great opportunity to increase the quality of products and services. Companies and especially SMEs get an opportunity to serve the arising niches as they go to a greater extent. Now we could further talk about what we could do to develop this kind of co-opetition. The problem is extremely complicated. We talked about it yesterday. I'd like to put it in a nutshell. We need to develop a new system for the market economy in which we would ensure to a greater extent cooperation between companies without giving up on competition. Now we have a president of the Polish Standardization Committee in the room, and he said something very interesting yesterday. Standardization is a prerequisite for this cooperation. It must be voluntary, but we need to define a platform so that a greater number of companies, especially SMEs, would have access to this know-how, to those standards, because they cannot develop those standards on their own. If we over-regulated the market, if we made those standards mandatory, then instead of stimulating innovation and increase will for cooperation and extend chains of value, expanding a shared business by mutual learning from each other, then we would conserve old technologies and we would impede competition. And then the old incumbent technologies would be preserved by standards as barriers. So we must avoid over-regulation. Regulation should be only necessary. Regulation should only ensure interoperability. Now, to enable interoperability, our colleagues from Z5 developed a project and presented a very important model that shows us that in the past, in order to combine telecom networks on a global scale very differently as compared to the area codes within nations, that standardization was insufficient. So then what was invented was an OC model. It had 7 levels. The layers were very simple. It was practically a one-dimensional model. Actually, right now, the problem is a 3-dimensional cubicle. We have different axes. We have a communication axis. This model is still mostly about communication. The physical layer is only the bottom layer. All the higher levels are directly associated with electronic communication, the business layer included. So including expert programs that are increasingly saturated with AI, and they are increasingly similar to human management. The other axis is about the generality. At certain levels, we're interested in products. At other levels, the scale of the product, then we have increasingly complex problems, including a global network problem. Every problem requires a different approach in terms of communication, preparation of data, and so on and so forth. And it's very clear for you that the same problem occurs for the life cycle of the product, from a raw material to waste. And again, we need to make sure that waste is recycled into raw material. So we need to move from a linear economy to a circular economy. I've put a number of points on this slide. I wouldn't like to explain everything right now. I want to touch on the things that you can't see directly from here. I'd like to draw your attention to two important issues, maybe less obvious. This reference model shows a fantastic philosophy for clarifying our thinking. It introduces certain semantics, vocabulary. Understanding of the problem is not something strange or bizarre. It's just a reflection of realities that is evolving. Obviously, reality is not as ordered as this cube, but the essence, the core of this model still is going to remain constant for many years, and it's going to work just as the OC model worked out in the future, and it encompasses all the issues inherent in businesses, small and big ones. Obviously, the number of layers may be reduced in the different dimensions, and this has happened in OC, which has not diminished the value of that model. Now, I would like to expand on this thesis. Now, a proof of the model is that within 1 to 3 years after the publication of the model by ZFI Association, the same schemes were used to present something else. Now, taking advantage of the fact that the RAMI 4.0 model is a dynamic one, it also has a fourth axis, the axis of time, which shows the dynamics of the processes. So this pathway related to dynamics is critical. Now, someone else analyzing technical issues moved to cloud, the Internet of Things, big data, a variety of migration technologies in different dimensions. It's a very different thing, but again, the implementation of this paradigm is similar. I have too little time to perhaps demonstrate it in detail, but this way of thinking has much wider application than Industry 4.0 alone. I'd like to emphasize the importance of the element of the base. Networks are based on some fundamental assumption. When we developed, let's say, electricity grids, we would have to decide, is it going to be AC or DC, what voltage, and so on and so forth. So we also had to develop some standards for the Internet. It started from IP packages, commutation of the line to commutation of packages. So the first basic thought became the subject of development that led to incredible revolution. And exactly the same solution was proposed by the German engineers in terms of building a digital image. Okay. In terms of reflecting what is at the bottom, this is a very elastic concept that makes it possible to freely, but in an addressable manner, add more technical documentation. It makes it possible to change the description of what is included in this shell, so it explains what is inside. It records the wear and tear, and it enables connectivity.
The machine that is created contains a number of elements. Therefore, it sucks in the digital information and documentation on its components. And to make the picture more blurry, it also indicates the connections. If something is developing, and this is called the digital shell, there is also the so-called administration shell, as they call it. This word management or administration is an apt one, because this is the right one. Digital management, standardized in a different way, without being connected to any standards. This is a great asset of this element. However, some elements should be standardized. Most probably there are file formats attached. Probably addressing will be standardized. IP in version 6 will make every asset addressable. And I believe that the number of addresses in the 6th version equals the number of atoms in the world, so we will not be short of addresses. Therefore, we have a tool that both deals with products and clusters. This is material management based on one standard. What is great about it? Everything is based on one idea, very, very simple and flexible. This is IP protocol based. There was a number of protocols created, but each of them was standardized. I won't be telling you how many of them there were. I'm not going to dazzle you with my knowledge. To cut a long story short, though these were dedicated for particular transmission and physical carrier, over time they were all removed. Unification turned out to be the best. IP package was enough. When they ran out of addresses number 64 bits, 16-bit, they switched to 128 bits. And remember one thing. When you're getting ready for Industry 4.0, you should think about the schematic presentation. How to organize management policy of commodities that is in line with machines and communication. It is connection of two plants. It's not the cost of each of the plants multiplied, but they'll be using the same language that provides a description to what is in the storage area. I simplified that, but I gave you an insight. Of course, we can give you more information. The 4.0 industry and languages. Each of these stands a chance to develop if we devote a separate conference to each, a multi-day training. Because when we go into details, we require practitioners' knowledge to implement it. This knowledge should be enhanced. It's not the topic to be discussed in this conference. These detailed descriptions are being created, and it is time to become interested, so that you know what it is like from the infrastructure side, what kind of mechanisms should be in place so that assets information is available and protected for your company. There is an outstanding benefit of this administration shell concept. Our knowledge on what we produce, what we've got on the table, about the machine in place, is pretty limited. We see this in sections, but once it is produced in millions of copies, it demonstrates new features. If we imagine that's the case, I'm not speaking about deep past. In big plants, we have seen this development. This is product amelioration cycle. What a product is, this information is sent outside. This is verified through interactions with other bits of information. like every single product information is confronted with the product batch, features, use features, reliability, something that is part of statistics that does not apply to a single unit. It goes to AI module that corrects the information, improves the information that is included in the type series of products. Imagine, this is a kind of psychic closed loop. We try to teach and learn on the machine and piece of metal or an alloy, anything that is our asset, be it the shape, for example. This is about the product and the feature. This is the difficulty of fast understanding. The tool's quality is equally good as IP protocol, simple and complex at the same time. This is the address that plays a plethora of roles. If we imagine something of this kind, it can operate well within the number of plants. Only then can it learn. In this schematic presentation, a loop happens in the real world. One plant and many plants. In order for it to produce the fastest economic effect, we need to start with the most efficient use, where it produces the greatest benefits. To the best of our knowledge, I showed this slide many years ago. It has been ignored. We need to choose the most interesting elements. The most interesting from the economic point of view is related to energy management and smart energy grids. Once the first problem is solved, we'll have ecological electric car and the general services. Healthcare services are the most important. If this problem is focused upon, technological alignment will follow, because this is the most proliferate kind of service. It would translate into organization of generally available services. Let's take a big picture into consideration. Anything connected with Industry 4.0 results in the closed circuit economy. This is the collection of knowledge we don't have. We cannot create circular economy because we don't know what the circle is composed of. There are proofs for that. So without the material circulation, matter circulation, energy circulation, insufficient knowledge makes us make wrong decision. So the big picture is a task for real, feasible and digital industry. This problem is of global nature. Europe is a technological leader beyond any doubts. Speaking about scales, Asiatic market is the front runner. There is a strategic goal to understand that this technology, just like IP, needs to become a global technology. It doesn't have to be rigid from the commonization point of view. Specific elements need to be commonized to be interoperable. Therefore, we have the tasks for business. These tasks are not only technical, are quite technical and business-like. It all starts with education, because the company's staff are not able to cope with the problem without external educators, adult lifelong learning. This general social knowledge needs to be translated into specialized knowledge. People need to know it makes sense. Then we can encourage them to engage in detailed work. And if we have this awareness, we can start the minimum standard introduction process, the version as we used to have in the past. We don't have to experiment. We made it with IP. We can do it with the administration show. we can use the knowledge on flexibility of network-based devices. This is all I want to tell you.